Hello everyone. This video is on section 8.7 titled Radical Functions. In this video I'm going to be going over a version of the section 8.7 Knewton Alta homework. Now please understand that the version I'll be seeing in this video, the questions I see, may or may not be exactly the same questions you see when you work on the assignment on your own. Alright, but the objectives will be the same, the types of questions will be similar, so I'm hoping that watching me here helps you in some way when you work on the assignment on your own. Alright, so here is the assignment page. You will not see the words preview of, you'll just see the title of the assignment, the mastery bar up here telling you how far along you've gotten, the objectives. Now it looks like there are 3 objectives in this particular section, this particular assignment. Then you have your questions related to a certain objective. And beneath each question there should be a feedback button, right, where you can send feedback to Knewton. You will not see this instructor cheat button, right, this is for instructors only. But you will see a more instruction button, which I would recommend use of if you're ever on an objective or a question that you're struggling with. Click on more instruction and some further reading material or videos will appear that you should look over, and hopefully those will help you out. Alright, so for this first question, the objective is, evaluate a radical function. Right? So these are functions, and you've seen functions before. Right? There's an input and an output, and remember, in a function, every value of the domain corresponds to exactly one value of the range. Right? So what we're doing here is evaluating, right? Just plugging in a value, plugging in some input, and seeing what the output is. And the function just involves a radical, right? A root. Okay. So I'll write out this first one here. We're given a function, a radical function, a 4th root function here. And we're asked to evaluate this function called f when the input, which is n, is -5. Alright, so here's the function they gave us, right? This, again, the name, you've seen function notation before. This function's called f. The input is called n, right? The input variable. And the output is f of n, and over on the other side of the equal sign is how you calculate the output. It's the 4th root of 5n minus 231. And they're asking us to find f, the value of f at -5. Right, so very simple, just replace n with -5 in this rule over here, in this 4th root. So pretty simple stuff, right? So we have 4th root of 5 times n, right? So 5 times -5. And then you have minus 231. And then we have the 4th root. Now this is, -25 minus 231. Right, -25 minus 231 be -256. Alright, but wait a minute. Wait a minute. Alright, this is an even root. Right, a 4th root, right? Square root, 4th root, 6th root. It's an even root. And the radicand, the expression inside the radical symbol, right? The radicand is a negative number. And we we've talked about this in videos before. All right, this has been brought up before if you've been following along, hopefully. Remember, when the even root of a negative number is not a real number. And that's really all we can say right now. We are at the point in this particular course with these assignments, we're at the point where we haven't seen imaginary numbers yet. So all we've been told to do for even roots of negative numbers is say that it's not real. So there's no output here. I have a real number input, -5, but the output isn't real. So we can't talk about plotting this point on the coordinate plane. There's a real input, n is -5. There's no real output. So back in the assignment, what they tell us to do is, enter your answer as, that empty set symbol, right? The little circle with the slash through it, if the function does not have a value, right? It's not a real number value. So that's what I'm doing here. The value of f at -5 is not real, and if you go to sets, you can see the empty set symbol, and that's what we have to do here. Now, you really have to pay attention with even roots, right? Is the radicand negative or not? If it's negative, the result is not real, and if it's not negative, then it is real, and you can actually type in a value. With odd roots, it's even easier, right? Odd roots, cube roots, fifth roots, seventh roots, etc. The radicand can be positive or negative, it doesn't matter, right? You'll have a real number output. But here I'm entering that empty set symbol. And again, after every question, whether you get it right or wrong, there is an answer explanation. I would highly recommend reading these, whether you're right or wrong. Right? If you're correct, you got it right, read through the answer, just glance through it just to make sure that you got it right for the right reasons, and that you didn't just get lucky. Or, they may have some sort of alternate method that you didn't think about that you might like better for whatever kind of question you're working on, and you might want to use that in the future. Now, if you got it wrong, definitely read the answer explanations. All right, make sure you can figure out where you went wrong, why you were wrong, and hopefully you'll learn from those mistakes and do better in the future. All right, so let's continue on. All right, the next question is on the objective, find the domain of a radical function. Now, hopefully you remember domain, right? Domain is the set of all the allowable inputs, right? All the values that I can plug in for my input variable and get a real number output. So this has to do with, again, the fact that you can't take even roots of negative numbers, because even roots of negative numbers are not real. So we want to plug in values here for z, right? Z is the input variable here for this function g. We want to plug in values of z that make the radicand not negative. So once again, then it asks us to write the domain in interval notation. Right. So once again, I'll write this function out. We'll talk about the domain. All right, so once again, I'm seeing we have this function called g. The input variable is called z, and the output is g of z, and it's calculated this way, the square root of -10 times z minus 5. Once again, we have an even root. Right? It is a square root. The index is 2. So that means that whatever's inside the radical, right, this expression here, the -10z minus 5, this cannot be negative. Because if it were, then we would have a non-real number, right, as an output. I want real number outputs right now. So another way to say that is that this expression inside the radical symbol, this radicand, negative 10z minus 5, if you can't be negative, that means you must be greater than or equal to 0. All right, so you set up this inequality here. This is what it means to not be negative, right? To be greater than or equal to 0, positive or 0, but just not negative. And then I solve this, and this will tell me what numbers I can plug in for z. So I would add 5, right? Get negative 10z must be greater than or equal to 5. And then dividing by negative 10. Now hopefully you remember your inequality stuff. When I divide both sides by a negative, the inequality symbol will flip. So instead of is greater than or equal to, is less than or equal to. Then 5 divided by negative 10 would be negative 1/2 when reduced. And there's a description of the domain here. Here are all the numbers I can plug in for z and get a real number output. I can plug in negative 1/2 for z, or any number less than negative 1/2. Now if you think of a number line, now I know they're not asking us to do a number line here, but here are values of z, and the number negative 1/2 shows up. There's negative 1/2, and we can plug in negative 1/2 is good because of the equal to part, and then all the numbers less than negative 1/2 can be plugged in for z. And here's a picture of the domain of this function. Right, there's the domain of g, right? This g of z. All the numbers I can actually plug in for z and get a real number output. But we're asked to put this in interval notation. Right? The domain of this function called g is any value from negative infinity up to negative 1/2. Always parentheses, remember, on the infinities or negative infinities because it's not a number. And then negative 1/2 is in the domain. It's allowed to be plugged in. I'd be taking the square root of 0, which is fine. So remember, I have the bracket there. And this is what they're asking me to enter. Right, the domain of g written in interval notation. Right, now, again, you don't have to make the graph if you don't want to. I personally like drawing a number line telling me, hey, what numbers can I use, and then put it in interval notation. But either way is fine. And then back on the assignment, right, we're entering this in interval notation. So parentheses and negative infinity, comma, up to negative 1/2, and then a bracket, right, rectangular bracket, and submit, and that should be good. All right, and once again, please read through your answer explanations. Okay. The next question is on the same stuff, right? Same stuff. Find the domain of a function, right? A radical function. So just state what values you can replace the input variable with and get a real number output. So once again, I'll write this function out and we'll talk about it. All right, so this time, the radical is an odd root, fifth root, right? G of z is the fifth root of negative 7z squared minus 15. Now because that's an odd root, the radicand, right, the expression inside, negative 7z squared minus 15, this can be any number. This can be any real number. It doesn't have to be positive or negative or not negative like with even roots. So the domain here is all real numbers. You can plug in anything you want for z. The domain is all real numbers. I can plug in a negative number for z, I can plug in a positive number for z, I can plug in 0 for z, and I'm hoping you remember the interval notation for all real numbers. That was just parentheses, then from negative infinity to positive infinity, close with parentheses, right? This this was the interval notation saying, hey, you can use any number you want, any real number you want at all for z. And it's that simple, right? You see an odd root, the domain is anything, right? Any real number at all. You see an even root, then the radicand can't be negative, has to be greater than or equal to 0, right? And you set up an inequality and try solving that. So a little trickier with the even roots, but odd roots, no problem, right? It's just parentheses negative infinity, comma, positive infinity, close parentheses there. All real numbers. Now, of course, there's also the fact that you can't divide by 0, right? If you ever see a denominator that could be 0, you might have to restrict the domain, but I don't think they're doing that to us in this particular assignment. Alright, next question, we're going back to the objective, evaluate a radical function. So once again, just taking a function and plugging in a number, plugging in some input, and seeing if you get a real number output. So I'll write this out and we'll evaluate it if we can. Alright, so here the function f of x, right? The input variable is x. The output is f of x, and it's calculated this way. The cube root of negative 10x plus 155. Notice that this is an odd root, right? Cube root. So the radicand can be any number you want, right? It's fine. It can be positive, it can be negative, it can be 0, doesn't matter. So we should be able to find an output this time, right? There should be an output, a real number output. And they want us to find f of 3, right? Evaluate f of 3. So that's just replace x with 3, your input with 3, and here's the output, right? The output would be the cube root of negative 10 times x, or 3, plus 155. This is negative 30 plus 155. It's the cube root of 125. And this is something you should know, right? 5 to the third power is 125. So the cube root of 125 is just 5. And there we go. Right. So yeah, the value of f at x equals 3 is 5. And remember what this means, or we're going to get to this eventually in this assignment. They're going to have us graph functions. This would mean that the ordered pair 3, 5, right? Input 3, output 5. This is a point on the graph of f. All right. And we don't need to know this just yet, but like I said, one of the other objectives is about graphing these functions. And it's just like any function, input, output, that forms an ordered pair, a point to plot on the coordinate plane. But right now, all we want is the output, 5. Right? So that's all I'm entering. Right? F of 3 is 5. And once again, please read through the answer explanations. All right, next question. Let's see, now we're getting to the objective. Graph a radical function by plotting points and determining its range, right? All right, so here we have one of these interactive ones where we move some points around. So here we're asked to graph the function, f of x equals the cube root of x plus 4 plus 5. Use the movable point to adjust the graph, right? So I'll go to a piece of paper, I'm going to write out this, and then I'll also show you the online graphing calculator. I think I've shown you this in other videos, Desmos, DESMOS.com. But first let me write this out on some paper and try plotting a hand-drawn graph of this function. Alright, so the function we're given is f of x equals the cube root of x plus 4, and then after that plus 5. Alright, so we're asked to graph this. So what I'm going to do is I'm going to make a little table, a little chart with inputs and outputs. And the inputs, the values of x I'm going to plug in, I'm noticing that this is a cube root. Right, so that means I can plug in anything, right? You know, the radicand can be positive, it can be negative, it can be 0. I'm going to plug in some values here so that I get nice perfect cubes inside the cube root, make it easy. So starting in the middle of this chart here, let's start, 0 is a perfect cube. So if I plug in -4 for x, right, if I plug in -4 for x, the cube root of, -4 plus 4 is 0. Cube root of 0 is 0 plus 5 would be 5, right? So on the graph of the function, right, so I'll put the coordinate plane down here. Right, start. Now again, this is just a hand drawing, so it might not be the best looking thing, but here's inputs x, and then outputs f of x, right, or y coordinates if you want to call it y. And then -4 on the x, -4 on the x, 5 on the f of x axis, or the y-axis if you want to call it that. So -4, 5 is a point on this graph. Then another perfect cube would be 1, right? 0 is a perfect cube, 1 is a, so -3 would also be a good input. If I plug in -3 for x, you'd have the cube root of 1, which is 1, plus 5 is 6. Alright, so -3 for x, 6 for y, or 6 for f, like that. Another point. 8 is another perfect cube, right? So 4 would be a good input. If I plug in 4 for x, we'd have the cube root of 8, which is 2, plus 5 is 7. So 1, 2, 3, 4 for x, 7 for y. There's 4, 7. And I could also go the other way, with get some negative radicands. If I plugged in -5 for x, we'd have the cube root of -1, which is -1, plus 5 is 4. So I have input -5, output 4. Input -5, output 4. So like there. -8 would be also good. So if I plug in, say, -12 for x, that'd be cube root of -8. Right, if I plug in -12 for x, cube root of -8 is -2 plus 5 is 3. So input -12. There's -12. Input -12, output 3. That point there. And you get this curve like this. Now I could keep going with this. You could plug in all sorts of points. But you get a curve that looks like this. Goes up forever that way and down forever that way. But a nice little cube root curve here. Yeah. Now I'll show you a better version of this on what's called desmos.com. Let's get off of this. But yeah, all I did was just like you plot any graph. You plug in inputs, get outputs, plot points. Right. Here's this. Yeah, this is desmos.com. And I'll just type in the function as it looked, right? F of x equals the cube root. Well, you know what? I know that the cube root is to the 1/3 power. I don't feel like finding the cube root symbol. So x plus 4 to the 1/3 power. Remember, that's the cube root. And then plus 5. And you see this graph here, right? And like I said, we know some points on this, right? We know that the point -4, 5 is on it, right? There it is there. We know that the point -3, 6 is on it, right? And I'm not going to plot all the points I just did on the previous page, but like you could point out that, hey, look at all these points I found are definitely on this graph. Now in the assignment, what you're going to do is, there's only one movable point, right? They're giving me a point here, right? -4 comma 5, right? The point -4 5 is on this, and like I said, -3 6 is also on it. So let's just do that. There we go, and there's this cubic curve. All you have to do is find one other point, really, that's on the graph. That's all you're doing with the movable point. Right? They gave us one point. You're just moving one other point to another point that would be on this graph, and it fills in the rest of that cube root curve, and that is all you're doing. So this is pretty simple. Pretty simple stuff. Just moving one point to a point on the curve. Yeah, and again, they make a little chart here and all that, but it's just like graphing any other function. All right. Next question. All right, same objective. All right, same objective. Another cube root. All right. And I'll put this on some paper and we'll make a chart and all that, and I'll draw a hand drawing, and then we'll come back, and again, it's just like the previous question where they give us a point. -6, -4 is on this, and I just need to move this other point to a point that's actually on the curve. All right, so just like before, I'm gonna make a little table with inputs and outputs, right? X and f of x. Now they already gave us one of these. Right? If x were -6, you'd be taking the cube root of 0, which is 0, minus 4 is -4, right? And then, -5, cube root of 1, which is 1, minus 4 is -3. There's another point. If x were 2, you'd have cube root of 8 is 2, minus 4 is -2. You'd have the point 2, -2. Then going the other way with, plug in -7, you'd have the cube root of -1, which is -1, minus 4 is -5. Plug in -14, you'd have the cube root of -8, which is -2, minus 4 is -6, and so on. Again, I can plot all sorts of points. Right, so again, horizontal axis is x, vertical axis is f, right, or y if you want to call it y. And then, yeah, just plotting all these points, -6 input. There's -6 and then -4 output. So there's a point. -5 input, -3 output. Right. -5, -3. There's another point. 2, -2. +2 input, -2 output. There's another point. -7, -5. There's another point. And -14. -14, -6. Right, and we get this curve here. Right, again, it's like this, like the other cube root, something like this. Right. But yeah, back on the assignment though, it's even easier than this. You just need, they gave us one point, -6, -4. You just need to move this movable point to another one. So how about 2, -2? That's the point on this curve, 2, -2. And see they fill in the rest of the cube root curve for us. Yeah, that's it. Just need to move that movable point to just some point that would be on the graph. Alright, moving on. Alright, so now we're back to the objective, finding the domain of a radical function. Alright, so they are doing that to us where we have a denominator with a variable. Right? Remember that also, denominators can't be 0. Right? That's because dividing by 0 is undefined. Alright, so once again I'll write this out and we'll talk about, the domain, finding the values of x that I can plug into this function and get a real number output. Okay, so you got two things to worry about here. One, once again, this is an even root. All right, it's a square root. So 1, the radicand has to be greater than or equal to 0. All right. The radicand can't be negative. And 2, right, so and at the same time, there's an expression with a denominator here. Right, there's a denominator with a variable. Right. So, and at the same time, the denominator can't be 0. Right. So we have to consider both things. Alright, so first thing, let's look at the radicand. Right? The radicand is, the expression underneath the radical symbol, -9 divided by x minus 4. And we have to make sure we get values of x that make this greater than or equal to 0. Right? This can't be 0. So when does this happen? Now, again, this is, I'm assuming you know how to do this. This is solving a rational inequality. This is going back a little bit in the previous videos, where I have a fraction on one side, 0 on the other, and then I list what are called the critical values, right? I'm going to say CVs, critical values, and they're what make that fraction's numerator and denominator 0. Well, the only critical value is x equals 4, right? The numerator is -9 all the time. That's never going to be 0. But the denominator will be 0 when x equals 4. Then I mark this on a number line, right? These are possible values of x. And here's the number 4. Now 4 can't be a solution. Right? 4 can't be a solution because it makes my denominator 0. Right? So it's an open point above 4. And then now I have all these numbers to the left of 4, all these numbers to the right of 4, and I plug one in, right? We test some values. When x equals 3, so I'll test, let's test, say when x equals 3, left side would be positive, and is a positive number greater than or equal to 0? Yes, it is. Alright, because you'd have -9 divided by -1, there'd be a positive number on the left and a negative number on the right. So these numbers to the left of 4 are solutions. So I'm going to indicate that with the little arrow here. And then to the right, say x equals 5, you'd have -9 divided by +1, that'd be a negative number on the left. And is a negative number greater than or equal to 0? No, so I don't mark those numbers. Alright, so these numbers are allowed to be plugged in. All the numbers less than 4, but not 4 itself, right? And again, that's because of the denominator thing, right? The denominator of this fraction was x minus 4, and that can't be 0, meaning that x cannot be 4, which we've already indicated here with the open point. So there's the domain, this picture. There's the domain when I put both of these things together, both of these considerations. And when I put this in interval notation, that's every number from -infinity up to +4, but not including 4. Right? Not including 4, so parentheses on the 4. Because once again, that 4 will make a denominator 0, and that's not good. Alright, so I can plug in, 3, 2, 1, 0, pi, square root of 2, -100, right? I can plug in any of these numbers I wish, and the output will be a real number, right? Because the radicand won't be negative. Alright, let me enter that. So parentheses, -infinity, comma 4, and then parentheses again, not a bracket. Be careful. Great. And again, please, right, read your answer explanations. All right. Next question. Same objective, right? Find the domain. And remember, if it's an odd root, you're fine, right? You can plug in anything, any real number. We saw one example of that. Just make sure you don't have denominators that'll be 0 though, right? If there are any denominators with variables. If it's an even root like this, then we have to worry a little bit. Remember, the radicand of an even root can't be negative, has to be greater than or equal to 0 in order for you to get a real number output. So once again, I'll write this function out. We'll state the domain. We'll find the domain. All right. So here this function s has an input variable z. S of z is the square root of 15z plus 8. Notice again it's an even root. So that means this radicand, right, this 15z plus 8 underneath the radical symbol, the square root symbol, has to be greater than or equal to 0 in order for you to get a real number output. So I set up this inequality and solve it, and this is simple enough. So z must be greater than or equal to negative 8/15. There's the domain. Z must be a number greater than or equal to negative 8/15. And if you want to draw a little picture of that on a number line, you can. Nothing wrong with that, right? So here's a number line that represent possible values of z. Negative 8/15, let's say, is here. And we're talking greater than or equal to, so negative 8/15 is in the domain, and all the numbers greater than that are to the right. Right, and then if I want to put this in interval notation, right, the domain, so the domain of s, right, the domain of this function called s is the numbers from negative 8/15 and up, right, negative 8/15 to infinity. Bracket on the negative 8/15, right, that is a number I can plug in for z, and that's fine. And always parentheses on the infinities, right, so there we go. I'm going to enter that in the assignment. So bracket negative 8/15, comma, infinity, then parentheses always on infinities. Great. All right, so the objective there with the find the domain of a radical function is over. Moving on, we get another question from the objective, evaluate a radical function. So again, just plugging in a number for an input, the input variable, and seeing if you get a real number output and what that is. All right, so here we have an even root. All right, this is a fourth root function. So hopefully, after I plug in my input of -2 for c, hopefully the radicand is not negative, right? Because if the radicand is negative, we're not going to get a real number output. Right? And we'll have to put that empty set symbol. So let me write this out. Alright, so here we have h of c equals the fourth root of -3c plus 75. We're asked to find the value of h when the input is -2. Right, what's h of -2? So that'd be the fourth root of -3 times -2, right, replacing c with -2, plus 75. This is 6 plus 75, that'd be 81, right? The fourth root of 81. And this is another thing you should know. 3 to the fourth power is 81. Right? We're talking fourth root, so I'm thinking of this as a fourth power. So this is just 3, right? Since 3 to the fourth power is 81. Right? So h of -2 is 3. Input -2, output 3. The ordered pair -2 comma 3 would be on the graph of the function h if you want to graph it on an xy plane or something like that, or a ch plane in this case. But all they want is the output 3. Right, so back here, h of -2 is 3. Great. Wonderful. All right. One final question looks like on this same objective, evaluate a radical function. I'm not even going to write this one out. I'll just talk it out. Hopefully you understand. So we have f of w is equal to the square root of 5w minus 101. So another even root. So I'm hoping that when I plug a number in, I don't get a negative radicand. Well, we're asked to plug in 4, right? What's f of 4? Well, replace w with 4. You'd have 5 times 4, which is 20, minus 101 would be negative 81. The square root of negative 81, an even root of a negative number. That is not a real number. This is not having a real number output. So I'm going to enter that empty set symbol, which is again under sets here, right here, because it's the square root of a negative, even root of a negative number. All right, and again, please read through the answer explanations. Wonderful. All right, so I should have just the last objective left, a couple questions. Graphing. All right, graphing. Once again, it's another cube root, like the previous two questions we saw. So this time I'm not going to draw it out. All right, you've seen me do 2 of these by hand, these cube root functions. Now, once again, they gave us a point, right? If x were 4, then the output would be the cube root of 0, would just be 0. So you see 4 comma 0 here on the graph. We just need to move this movable point to a point that would be on this curve. So like 5, 1. If x were 5, you'd have the cube root of 1, which is 1. So input 5, output 1. There. All I need to do is move that movable point to one point that would be on this graph. That would be on this function. And then they draw the rest of the cube root curve in for us. Very simple. I'm hoping that's simple. Alright, and then again, please read through your answer explanations. Alright, and this should be the final question. Another cube root question. Now, you might come across square roots. Just be careful. Alright, pay attention to the root. The 4 questions I've seen have had cube roots. And they also talk about determining the range in the objective. Remember, the range is the set of outputs. So you're going to look at your graph and look at the vertical axis and see what points line up with values of the vertical axis for the range. But you've seen how to find the range of a function before as well. So again, I'm just going to talk this one out. The point 5, negative 2 is on the graph. They gave that to us. If I plugged in 6, right, you'd have the cube root of 6 minus 5. Cube root of 1 is 1. 1 minus 2 is negative 1. 6, negative 1 would be another point on the graph. And that's all I'm asked to do for these graphs here, is move that movable point to another point on the curve. And they fill in the curve for us. Now, the domain's all real numbers, right? The range would also be all real numbers here if they asked you for the range. The only time it gets trickier when the domain and range are not all real numbers is when you have an even root. Right? So if you ever come across even root problems and you're having trouble, just send me a message. Let me know. Or do the more instruction stuff. Try to help yourself out first before you contact me. All right? I want you to that you'll learn it better. It'll stick in your mind better if you're struggling with it and you try to learn it on your own. Alright, and that should be it for this assignment. And as I said at the top of the video, every question I saw here isn't, they're not going to be exactly the same questions you see when you work on the assignment yourself. But the objectives are the same, right? The kinds of questions are similar. So I'm hoping that watching me go through these 12 questions here helps you out in some way when you're working on the problem, the assignment, on your own. And thank you very much for watching.